In this video I will explain about scattering. So students, when light ray coming from the sun enter the earth's atmosphere, it gets scattered. Means simply when the light ray, suppose this light ray is coming, okay, so it gets scattered. That is the light spread in all direction by the dust particles and air molecules present in the atmosphere. You may see the path of the light ray entering a dark room through a fine hole because of scattering of the sunlight by the dust particle present in its path inside the room. The scattering of light was first studied by the scientist Rayleigh. So scientist Rayleigh has given a formula also that I will explain. First thing, I think I just read from your book or whatever I read. So when light ray come from the sun ray, it will fall on the dust particle. So dust particle should be small size, then wavelength of light, you must remember this point. If dust particle means dust particle bigger size than the wavelength of light is also present in the atmosphere. Dust particle small size, then the wavelength of light also is present in the, but the what happened due to particles, those are smaller size than the wavelength of light, they will absorb. They will absorb the light ray, then they will re-emit. They will absorb it. So that absorption and their re-emission in all direction, that you can say as scattering. That is the scattering of light. So Rayleigh first see this phenomena and give a formula. Rayleigh's law, give a law that scattering proportional to 1 by wavelength to the power 4. Wavelength to the power 4. That means wavelength of the light increase means scattering will decrease. That means now students you understand, that means wavelength increase means rate higher wavelength. So rate scatter higher wavelength means scatter least, and violet scatter more, because violets you know rate Vibzior V2R VIB, all you know, it is 400 to 800. 400 nanometer to 800 nanometer. So violet is, this is the value of lambda, so red is higher lambda. So higher lambda means scatter least, higher lambda means scatter least according to the Rayleigh's law. Scattering is proportional to 1 by wavelength to the power 4. That formula has given by the scientist Rayleigh. So students, Vibzior, once again I am writing here GYOR. That means in Armstrong, if I say the value 4000 to this is 8000 Armstrong, and these are the value is coming in between it. That means its lambda is small in these three purpose if I say, and here below side you can say lambda is generally large. Lambda large means scatter least. Now directly we will moving to the applications. I think you can understand the scattering, that when light ray coming from the sun, it will absorb by the dust particle. Scattering from the book I am reading, scattering is the process of absorption and then re-emission of light energy by dust particle and air molecule present in the atmosphere. So directly I move to the applications. So one thing I am just saying here, when student particle size equivalent to light wavelength, light wavelength, all colors scatter equally. All color scatter equally, you just remember this thing. All colors scatter equally. So when particle size is equal to the light wavelength of the light, then all color scatter equally. But when smaller size, then different color absorption and re-emission happens, and proper scattering you can say. And why this both is important, that I will explain when you read the applications. So application first, you can say that red color, red color light, red color used for danger sign. Okay, means red color used for because it is least scatter. Why least scatter? Least scatter red color because lambda more. Lambda more means wavelength more. That means our students least scatter means travel long distance. That means suppose that is red light, it will directly come if your eye is here. But if another color, if I say about violet, indigo, blue, suppose blue, it will scatter and very less amount will come if your eye, eventually it can vanish in middle. Okay, if it is blue. But if it is ray, it will directly go without scattering because it is least scatter. Now three condition is very important. First, you can say that sky appear blue. Most of the time sky appear blue, most of the time. Okay, and another condition you can say sometimes sky also appear red. Sky appear, that all, that condition, that phenomena, that condition also we will explain. I will explain and we learn that sky appear red during sunrise and sunset. Okay, just digest my writings. I hope you can consider my writing. Okay, so students, suppose sun and that is the earth. Okay, so earth has the atmosphere. Atmosphere has the particles and molecules. When light ray directly come like this, it will refract it. Okay, it will refract it. Okay, when because it will changing its state from vacuum to the from rarer to the denser medium. It is coming, atmosphere is denser medium, so it will refract it. Here if you consider the normal towards the normal like this way, you just remember that when light ray coming from the sun, it will refract it. Okay, so refraction happens. Now students, all dust particle present, okay, dust particles present, you know, they will scatter. Scatter which light scatter more most, you know, red scatter least. So scatter more means that above 3, there where the wavelength is less, that means violet, indigo, blue. So when light ray is falling, coming inside the atmosphere, which color is scattering most? That violet, indigo and blue. Okay, they will scatter most. That's why that color is spread away. Okay, this generally this color is spread in the sky. That's why we watch it's blue. Okay, as blue is scattering most, so the color is looks like these three color is together, they will scatter more and it will looks as blue. But student, when during the sunrise or sunset, suppose there is the earth, so sun is around about the horizon. Suppose this is the horizon, these are the atmosphere. So the light ray moving a long distance. Okay, then refracted. Okay, so light ray moving very long distance. Now students, long distance can move only by the red light, red wavelength or red light you can say, or yeah, red light. Because student, because red scatter least. That's why up to when as very long distance light ray is traveling, okay, VIB, violet, indigo, blue, that three color will scatter away totally. Okay, so all scatter away. uh, they will lost, scatter and lost. So just you can say only red light is appear, only red light can travel. So that's why red, orange, yellow, that kind of looks you can see. Okay, a reddish types of color you can see because they are scatter least. Okay, their wavelength is more. Okay, now students, third point, sky appear white. Why sky appear white? You know, if that happens during the mid time. Okay, you can say suppose here it is earth. you know, sun is here, okay, midday, you can say 12 noon. At that time it look white, and in between it is looks like blue, and at horizon it's look like red. Okay, that two condition I already explained, blue and red. So why it's happier white? Because it is very shortest distance moved by the rays, light travels. So that's why all colors scatter equally. That's why all color together it will consider as white. So as all colors scatter equally, earth it's look like sky means sky appear white. Okay, sky sky appear white. Okay, here sky appear red sunrise. And I hope student these three condition, and that is three important condition comes in the exam. And I hope you can answer it. Okay, so that is the end of the lecture and end of the chapter. Thank you.